Hi friends, hope you are watching my videos on the automobile subject. My channel name is Bhaskar Peddakotla. So far, I have released 67 videos in English and simultaneously in Telugu explaining about the automobile subject right from engine through the powertrain components till the wheels and the steering system, brake system, suspension system, etc. Now, I am releasing two more videos on the electrical vehicles. Now, the majority of the people are inclined towards using the electrical vehicle due to the advantages of the electrical vehicle over the conventional vehicles. So, first video I am going to explain about the critical components of the electrical vehicle, how they function, and the next video I will be talking about the difference between the conventional vehicle run with the internal combustion engine and the electrical vehicle. It is estimated that every year around 8 crores vehicles are being sold throughout the world. Imagine the amount of pollution created by this huge population of vehicles running on the road and which is causing health problems to the human being living on the earth. So it is essential to minimize, if not 100% preventing, to minimize the pollution, and the only option available is to replace the internal combustion engine with an electric motor. Let's have a brief look about the two vehicles. This car is powered with internal combustion engine, whereas this car is an electric vehicle. What is the difference? The shape of car is identical. The tires are identical, axles are identical, seats are identical, headlights are identical, everything is identical except the one prime mover which turns the wheels. In case of this vehicle, it is an internal combustion engine which runs by burning the petrol or diesel. So when the fuel is burned inside the combustion chamber, a lot of byproducts are released through this exhaust, that is carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxide, etc. All these harmful gases are released. Here, there is no burning of fuel at all. So when there is no combustion, wherein there is no burning of the fuel, no exhaust gases, no pollution, that is the main difference. So a motor is replaced here with the engine and the fuel tank is replaced with the battery. Just observe this chart. In the past 6 years, the sale of electric vehicles have increased to 14 times. In 2016, approximately 5 lakhs electric vehicles were sold. This is millions. 0.5 million electrical vehicles were sold. When it comes to 2022 end, approximately 5.21 plus 1.91, 7 million vehicles means 70 lakhs vehicles have been sold. From 5 lakhs to 70 lakhs. So there is increase of 14 times for a period of 6 years. And in the coming 5 years, this figure is going to be approximately 16 millions, means 1.6 crores vehicles. Undoubtedly, the future will be of electric vehicles. How this will work, we'll have a brief look. The figure what I am showing here is the car, which is called all electric vehicle. There are 4 types of electric vehicles we will see. Of course, the majority of the cars are all electric vehicles only, and the other 3 types are the plug-in hybrid electric vehicle. Hybrid itself represents the vehicle will be having both internal combustion engine and also the battery pack. The third one will be hybrid electric vehicle. The fourth one will be fuel cell electric vehicle. So for easy understanding and clarity how an electric vehicle functions, let us discuss about only the all electric vehicle. So critical parts of the all electric vehicle is The first one is the traction battery pack. So this stores electrical energy like a fuel tank in the IC engine vehicle. This is the traction battery pack. How the traction battery pack we will discuss in the coming slide. The next component is the electric traction motor. The traction motor runs with the electrical energy received from these batteries. The third component is the inverter, which converts this DC power from the batteries, direct current power from the batteries, into the alternate current, AC current, because motor works with the AC current, whereas the batteries supply the DC current. To convert the DC into the AC, the inverter is used. The other job of the inverter is when the brake is applied on this electric vehicle, the motor acts as a generator. So motor generates the power. Instead of consuming, it generates the power. So when it generates the power will come in the reverse direction through this inverter and used to charge this battery pack. During that time, the AC power from this motor is converted into DC power and the batteries get charged. The other component below this is the controller. This is also called electronic control unit, okay, which is the brain of the vehicle. The job of the controller is to give the command to the inverter to supply the required amount of current at required amplitude levels so that motor revolves as per the driver need and as per the driving conditions. That's why the controller is called the brain of the vehicle. The controller takes the signals from the acceleration sensor and it will be having a computer chip inside and decides and accordingly send the signal to the inverter. The other component is the auxiliary battery. This is provided to give the power to the headlamps, tail lamps, indicators, instrument panel, etc. etc. Okay. This is a 12-volt battery, whereas this battery pack will be between 300 volts to 400 volts depending upon the design of the car. Next one is the DC-DC converter. To charge this 12-volt battery, a step-down converter is required. So the DC power is coming here with 300 or 400 volts and it is stepping down to 12 volts and then the battery getting charged. Next one, the thermal cooling system. There is a heat exchanger. The vehicle is running. When the batteries are discharging the power to the electric motor or when the batteries are getting charged from external power, the heat is generated inside the system. To dissipate the heat exchanger is required. The next one is the on-board charger. A charger is provided inside the vehicle itself so that we can plug into the domestic supply and these battery pack can be charged. But the only issue is it takes long time to charge these batteries from this onboard charger because the amount of voltage or power supplied to this charger is a domestic power supply. It takes almost 13 to 15 hours. Another one is the charge port where a plug is connected from the commercial charging stations. So the commercial charging stations are heavy duty chargers. There is no charger here, it is only a port. Okay. Charger will be outside the vehicle in the charging station. So when you connect to this port, it takes 3 to 4 hours to charge these batteries. Of course, there are rapid chargers. It's few places which takes 30 to 45 minutes to charge the batteries, but it's not advisable because the temperature rises in the system if you keep on doing the rapid charging. Rapid charging has to be used only in case of emergency. Let us look at the detailed construction of each and every component. This is the battery pack in the vehicle. The battery pack is arranged, traction battery pack is arranged on the platform of the car to have uniform load distribution. These are the lithium ion cells. Some cells will be in the cylindrical form, like Tesla company and all, they uses the cylindrical cells. The capacity of each cell will be having 3.4 volt DC. Like that, a set of cells are arranged to make as a single module. So a module will be having multiple number of cells. Again, these modules are connected in series and arranged on the vehicle platform. This is how cells are arranged. So this is each module. So each module is having again multiple number of cells. So the cells, individual cells are connected both in parallel and in series to give voltage of 300 to 400 volts. This variance 300 to 400 volts depending upon the vehicle design. The cross section or internal construction of a lithium ion battery, if it is a flat cell or a rectangle cell, it is look like this. The blue one is the negative electrode or a cathode, okay, and the red one is the positive electrode or anode. There will be liquid electrolyte between these two, and to separate that one there are separators. These silver colors are the separators, so that both anode and cathode do not touch each other. And all the anodes are connected to the one terminal, all the cathodes are connected to the one terminal. So negative terminal and one will be the positive terminal. Okay. And the cylindrical cells construction will be like this. So the green one and the yellow one. Green one is the anode and yellow one is the cathode. You can see there is electrolyte inside it, and the black lines are the separators. So they will be rolled in a cylindrical form and sealed at one place, and the cathodes are connected. The complete cathode strip is connected to one pole and anode strip is connected to the one pole. The cross section of the cylindrical cells looks like this. And the next advancement of this lithium ion cell is the solid state battery. These batteries do have the liquid electrolyte, whereas solid state battery do have a solid electrolyte. The advantage of solid state battery is there will not be any leakage in the battery. So individual cells of approximately 3.4 volts are connected in series and parallel both to form a 300 volts to 400 volts output supply. All the batteries are lithium ion batteries. The next component is the motor. Various types of electric traction motors are being used in the vehicles, whereas the majority of the vehicles uses the brushless DC motor. The illustration explains about the brushless DC motor. This is how the brushless EC motor parts look. First one is the stator. Because it will not rotate, it is a stationary member, it is called the stator. The stator is having electrical windings, okay, circumferentially 3 to 6 places, right? So power is supplied to these electrical windings as and when required, as and when we want to rotate the motor. The center one is called the rotor, which is made with a permanent magnet. To give frictionless rotation, both ends of the rotor is supported with the bearings, and these are seated in the housings at both ends. To secure this complete unit rotor and the stator, a strong housing is provided. So complete assembly is securely assembled inside the motor housing. How it works? Let us see. So the electrical current, when the electrical current passes through this coils, a magnetic field is created, electromagnetic field is created, and below there is already a permanent magnet. So when the magnetic field is created, as per the principles of magnetism, the opposite poles get attracted each other. Next pole is electromagnetized, it will be pulled towards like this. Same way, this pole is magnetized, it will be pulled like this. The repulsive and attractive action of the magnetic poles makes the rotor to rotate. And this, all the motors are the bidirectional motors, so they will rotate in both the ways, clockwise and anti-clockwise, depending upon the driver's requirement. The capacity of the motor will vary from 50 kilowatts to 200 kilowatts in the cars. In case of buses, it will be more. When it comes to the lasting of the battery charge, or the to what distance a car can be traveled, means the battery packs, as far as the voltage is concerned, supply voltage is concerned, it is 300 volts to 400 volts. When it comes to the efficiency or the capacity of the battery, it will be normally 40 kilowatt hour. It is rated in the kilowatt hour. Okay. What is mean by kilowatt hour? Means a 100-watt bulb. If we glow in our house for about 10 hours, the power consumption is 1 kilowatt hour. 100 watts into 10, that is 1 kilowatt. Same way, the capacity of the battery pack in the passenger cars will be from 40 kilowatt hour to the 100 kilowatt hour. Suppose a car consumes at an average of 20 kilowatts. The charge of this battery lasts for about 2 hours, maybe around 100 to 120 kilometers the battery can come. So if that battery charge is approximately 60 to 70 kilowatts, that battery will come around 3.5 hours to 4 hours. After the motor, the next one is the transmission. Here in electric vehicles, the transmission is a very simple one. It is a single reduction transmission, unlike the multiple gears in the conventional vehicle. There the multiple gears are required because the engine runs between 600 to 6000 rpm in case of petrol engine. In case of diesel engine, it will be between 600 to 3000 rpm. Whereas in case of electric vehicle, the motor runs from 0 rpm to 20,000 rpm. Okay. To reduce that speed means to increase the torque, a single step down transmission is provided here. So at one stage, the speed is reduced here, this transmission. Okay. And the speed variation is taken care by the motor itself with the help of the controller. And this is the differential. Differential purpose, you all know, this is mainly provided to give the differential speed between the inner wheel and the outer wheel when a vehicle is negotiating a turn. Because when you are negotiating a turn, the inner wheel has to rotate lesser speed than the outer wheel. To give the differential speed, the differential mechanism is provided. So it is provided inside the transmission. The transmission gear shift lever looks identical to the automatic gear shift lever in the conventional vehicle. Normally, the 4 marks will be there. P or ND. P means the vehicle is in parking, so it will not move. So power will not go to the motor at all. R means when we want to take the vehicle reverse direction, you have to put in R. So the motor will rotate in the reverse direction. N means neutral. Motor, so it will be neutral. Then D means forward. So there will be forward speed variation will be there depending on the current available at the motor as per the driver's requirement. Transmission is over. The other components, let's have a look. Power is stored by the battery pack. Motor rotates whenever the driver wants to rotate with the help of battery power, and the electrical power here in the electric motor is converted into the mechanical power, and same is supplied to the transmission, then differential, then to the wheels. What controls the motor RPM and the motor torque is the controller. It's a kind of electronic control unit. It takes the signal from the accelerator, which is under the control of the driver. So by taking the signal from the accelerator to increase or decrease the speed, it takes into its computer and synchronizes the machine with the vehicle's load. Then accordingly, command is sent to the inverter. The job of the inverter we have already discussed, to convert the direct current into the alternate current, AC current. So the controller send the command to the inverter, yes, you supply this much of current at this amplitude, okay, to this motor. Amplitude is to decide the speed of the motor. Current is to decide the torque of the motor. So accordingly, the inverter supplies the required amount of current at required amplitude to the electric motor. So converter is over, controller is over. Then the auxiliary battery already we have discussed to function these headlights, tail lamps, indicators, this instrument panel, etc. This is DC to DC to charge this auxiliary battery from higher voltage to the lower voltage. Then cooling system to dissipate the heat generated during the charging and discharge of the batteries, the heat exchanger. Then onboard charger provided inside the vehicle to take the supply from domestic line and charge these batteries, which takes 15 hours approximately. Then charge port used provided to charge the batteries within 3 to 4 hours from the commercial charging stations. These are all the different components in the electrical vehicle, and other components like steering system, suspension system, brake system, etc. will be identical to the automobile, which is powered by the ICU, that is internal combustion engines. The other three type of electric vehicles we can have a look. This is plug-in hybrid vehicles. Plug-in means this is to charge from the charging station. Of course, onboard charger will be here. So this is the engine, internal combustion engine. There will be a generator inside. The engine runs, generator runs, and from this generator, the battery is charged parallelly. When the vehicle is stopped, the batteries can be charged from the charge port as well as from the onboard charger. Of course, there will be fuel tank. This is called hybrid vehicle because it is having both internal combustion engine and as well as the battery pack motor. Now it is pure hybrid vehicle. There is no any plug-in. No external power is required. No onboard charger. It is having a diesel engine, motor, generator, and battery pack and diesel tank or the fuel tank, whatever may be. Okay. Engine runs, generator charges the batteries, and again battery power used to run this motor. So if you want to run in electrical mode, you can switch out electrical mode. Otherwise, you can run in the fuel mode. The other type is the latest advanced one is called hydrogen fuel cell electric vehicle. Honestly, I do not know about this technology, but I can brief you. The electricity is generated from the hydrogen cells and the battery pack is charged and the electrical power is supplied to the motor. This is briefing about the electrical vehicles. Hope the content is useful to the viewers. Request you to subscribe to my channel and ask your friends also to subscribe to my channel and watch other videos. In the next video, you can see the differences between the electric vehicle and the vehicle with the IC engines.